Now, this is about the naming of alkenes. Alkenes have general formula of CnH2n, while the naming of alkenes using the rules similar to those for alkanes. But we changed something, that is the ANE should be ending it up with ENE. That is alkenes because it is ending with ENE. So for the first two members of the alkenes should be ethene or propene. So for the naming of alkene, first of all, they should have general rules for the alkenes, and then we change it to ANE to become ENE. The suffix will be changed a little bit. And then we need to assign for the CC double bond groups to have the smallest number. So if it is very obvious, just like the one that we have in the general rules for alkanes, if it is obvious that's the number of the functional group, so for example, ethene, in fact, it must be the first two carbon involved the CC double bond. We don't need to add any one or two there. Or the next one about the propene, if we find that it is very obvious that it starts with one, the first carbon, no matter it is starting with the left-hand side or right-hand side, in fact, it is the first carbon encountered the CC double bond. As a result, we will not say pro-1-ene. Instead, it is propene. So, for an alkene having 4 or more carbon atoms in the main chain, a numeral will be given for the name and indicate the position of the carbon-carbon double bond. For example, for this one, it is butyl-2-ene, just because, in fact, there may be butyl-1-ene in the world. So, when we label this one as the butyl-2-ene, this one will be the butyl-1-ene. We start the numbering of the carbon atoms from the end closest to the double bond. That means we will not count it the butyl-1-ene as the left-hand side starting as 1, 2, 3 as butyl-3-ene. Instead, we will starting on the other side, that is here, on the right-hand side. 1, we have the carbon-carbon double bond already, so it is butyl-1-ene instead. So give the lowest possible numeral to indicate the position of the CC double bond. If there is any methyl group as the substituent, so we still assign the CC double bond first. The CC double bond will be assigned as smallest as possible, so it would be assigned as 2. While although the carbon chain can be counted the right-hand side as 1, but as this one, if we count it on the right-hand side at 1, then the 4th carbon will have the CC double bond, so it is not preferred. As a result, we have to start with the carbon-carbon double bond starting as early as possible. So we have a 6 carbon chain, 6 carbon atoms in the chain. So it is starting with the S. And then there should be a double bond at the 2nd and 3rd carbon. So smaller number is 2, so we take 2. So it has 2 in. While there is a prefix, the prefix is about the substituent. It is the methyl group at the 4th carbon. So we have 4 methyl has 2 in. So this is the prefix, and then this will be the root, or what we call the parent chain. So naming of alkenes, if there is more than 1 carbon-carbon double bond, but in fact, we will not say this is an alkenes because alkenes should have 1 CC double bond only. But some of the hydrocarbons contain more than 1 CC double bond, carbon-carbon double bond. As a result, here, we will not say they are alkenes anymore. In fact, we will say that they are alkadiene. And choose the longest continuous carbon chain with the maximum number of carbon-carbon double bonds is needed. And then we need to end up with the diene, triene, etc. If more than 1 carbon-carbon double bond, 2 carbon-carbon double bonds instead, then it will be treated as diene or triene. So depending on the number of carbon-carbon double bonds, we choose diene or triene respectively. For example, for this one, for the examples, this one, we will name it as we have 1 and 2 two CC double bond at all. So we say that this is 4-methyl penta 1,3-diene. So because we have the first carbon and then the third carbon, we have the CC double bond. So it contains diene. And then the position should be 1,3. The longest carbon chain should have 5 carbons, so it should be penta. And then at the fourth carbon is have a methyl group. So this is the methyl group as a substituent. As a result, it is 4-methyl. But here, one more rule. If it involves diene or triene, then the A should be retained. Just like the name of the parent alkane, then we have alka. So it will start with penta. That is, this A should be present all the time. So instead of omitting the A to become CNE, we have to leave it back pentadiene, just like the one that we have in the alkane. Now, also, I want you to take a look for this one and count the number of carbon and number of hydrogen this time. Once you consider about the CNH, here we have C5, we have 5 carbon, and then count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be having C5, sorry, I have missed it some. In fact, this one contains also 1 carbon here. So it should be starting with C6, not C5. So it should be C6 and then C6H10. Now, why I want to stress on the molecular formula now? Just because when you find that, in fact, for the alkene, alkene, if it is an alkene, it should be C6H12. But at this moment of time, it will become C6H10. As a result, what we call the previous one is not the same case. If you remember the same homologous series, we should have the very, very important rule. They should have same general formula. They should differ with the neighboring member by CH2. They have the similar chemical properties, and they should have a gradual change for physical properties as well. Now for here, if we say that more than 1 carbon-carbon double bond, it should not be named as alkene. Instead, it should be named as alkadiene. Just we like here, alkadiene is CnH2n-2. That is the one that we have, it is C6H10 instead. But if for the general alkene, it should be C6H12. As a result, in fact, we cannot say some alkenes have more than 1 CC double bond. So the better word should be some hydrocarbons have more than 1 carbon-carbon double bonds. So let's try to name about this. This one, we say that it is for the first carbon is already encounter the double bond. And then there is another double bond, carbon-carbon double bond on the third carbon and the fifth carbon. So that means there should be 3 double bonds. So 3 double bonds triene. And then on the first carbon, third carbon, fifth carbon, we have the CC double bond started. As a result, it is 1,3,5 triene. And then the longest carbon chain, it should be heptane. So it should be CC double bond involved. So it should be heptene. However, triene presence, we need to keep the A here. So the parents or the roots should be hepta 1,3,5 triene. And then we can find that there is a substituent, that is the C2H5. So we need to name it as ethyl group here or ethyl group here. The ethyl group, we label it on the 5th carbon presence, the ethyl group. So this is the 5-ethyl hepta 1,3,5 triene. So don't forget, the A should be retained. If there is another substituents, so just take chiral group as an example. Now, the functional group is it should be arranged first. That is, this should be taken the lowest one. instead of the substituents. So the prefix, we will still assign it as dichoral because we have two choral groups attaching to the third carbon, and then the first carbon remove the CC double bond. So it would be propene because the propene must be starting with the first carbon. It cannot be another way. So we don't need to label as pro-1-ene, but we need to label the position of the choral group because it may be 2,3, it may be 1,1, etc. So we need to label the dichoral as 3,3 dichoral propene. Next one, about this one, 4 carbons at all. So it should be butene. But first carbon encounter the CC double bond. As a result, it is but1-ene. And then once we assigned that the functional group has the smallest number, then bromo group will be fourth carbon at the fourth carbon. That is 4-bromo-but1-ene. Some more examples here in our notes. This is the CC double bond on the first carbon. So it will be 3-choropropene. While for this one, a longer one, 1, 2, 3, 4, 5, 6, 6 carbons altogether. So it should be hexane. And CC double bond present, hexene. With 2 CC double bond, hexadiene. But don't omit the A, so it is hexadiene. The position labeled as here as the first carbon. So hexa-1,4-diene. So the prefix that we got so far, apart from the one that we have, foro, choro, bromo, or aldo. In fact, if you want to learn more, there will be some more here. So, but we need to know the foro, choro, bromo, aldo, and then the alkyl one, that is the methyl group, ethyl group, etc. Otherwise, for the al-oxo, azole, nitro, nitroso, and then so on and so forth. In fact, it is not in the DSC syllabus. Just for your reference, if we have these groups here, then we will have such prefix. So for the one, if you didn't mark down the answer, so you may try it now.